Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube.
Good morning. Today I am discussing about fuel system. Actually, the fuel oil may be delivered at the plant site by trucks, railroad, tank cars or barge and tankers. From tank car or truck, the delivery is through the unloading facility to main storage tanks, and then by transfer pumps to small service storage tanks known as engine day tanks. Large storage capacity allows purchasing fuel when prices are low. The main flow is made workable and practical by arranging the piping equipment with the necessary heaters. The process here, the main flow is made workable and practicable by arranging the piping equipment with the necessary heaters, bypasses, shut-offs, drain lines, relief valves, strainer and filters. Flow meters, temperature indicators. The actual flow pans depends on type of fuel, engine equipment, search of the plant, etc. The tank should contain manholes for internal access and repair, fill lines to receive oil, vent lines to discharge vapors, overflow, return lines for controlling oil flow, and a suction line to withdraw oil. Coils heated by hot water or steam reduce oil viscosity to lower pumping power needs. The minimum storage capacity, at least a month's requirement of oil, should be kept in bulk, but where advantage of seasonal fluctuations in cost of oil is to be availed, it may be necessary to provide storage for a few months' requirement. Day tanks supply the daily fuel need of engineers and may contain a minimum of about 8 hours of oil requirement of the engine. These tanks are usually placed high so that the oil may flow to the engine under gravity. Here the flow system is shown here: bulk storage, another one is the fuel unloading line, strainer to strain something, meters, day tanks to engine. For satisfactory operation of a fuel oil supply system, the following points should be taken care of. There should be provisions for cleanliness and for changing over of lines during emergencies. In all suction lines, the pipe joint should be made tight. Before being covered, all oil lines should be put under air pressure and the joints tested with soap solution. Small air leaks into the line can be the source of exacerbating of operating difficulties and are hard to remedy once the plant is in operation. The piping between filter and engine should be thoroughly oil flushed before being first placed in service. Considerable importance should be given for cleanliness in handling bulk fuel. Dirt particles will ruin the fine lap of injection pumps or plug, the injection nozzle orifices, so high grade filters are of paramount importance of the diesel oil supply system. Now, fuel injection system. The mechanical heart of the diesel engine is the fuel injection system. The engine can perform no better than its fuel injection system. A very small quantity of fuel must be measured out, injected, atomized, and mixed with combustion air. The mixing problem becomes more difficult the larger the cylinder and faster the rotative speed. Fortunately, the high speed engines are the small bore automotive types. However, special combustion arrangements such as pre-combustion chamber, air cells, etc. are necessary to secure good mixing. Engines driving electrical generator have lower speed and simple combustion chamber. Fundamental of injection system. Filter the fuel, meter or measure the correct quantity of fuel to be injected. Time the fuel injection. Atomize or break up the fuel to fine particles. Property distribution the fuel the combustion chamber. The injection system are manufactured with great accuracy, especially the parts that actually meter and inject the fuel. Some of the tolerances between the moving parts are very small, of the order of 1 micron. Such closely fitting parts require special attention during manufacture, and hence the injection systems are costly. Types of fuel injection systems. The following fuel injection systems are commonly used in diesel power station: common rail injection system, individual pump injection system, and distributor. Atomization of fuel oil has been secured. Air blast, pressure spray, early diesel engine used air fuel injection at about 70 bar. This is sufficient not only to inject the oil but also to atomize it for a rapid and thorough combustion. The expense providing an air compressor and tank lead to the development of solid injection using a liquid pressure of between 100 and 200 bar, which is sufficiently high to atomize the oil. It forces through spray nozzle. Great advances have been made in the field of solid injection of the fuel through research and progress in the fuel pump, spray, nozzles, and combustion chamber design. Operation of a diesel power plant. When diesel alternator sets are put in parallel, hunting or phase swinging may be produced due to resonance unless due care is taken in the design and manufacture of the sets. This condition occurs due to resonance between the periodic disturbing forces of the engine and natural frequency of the system. The engine forces result from uneven turning moment on the engine crank, which are corrected by the flywheel effect. Hunting result from the tendency of each set carrying. For best operation performance, the manufacturer's recommendation should be strictly followed. In order to get good performance, the diesel power plant, the following points should be taken care of. It is necessary to maintain the cooling temperature within the prescribed range, or use of very cold water should be avoided. The cooling water should be free from suspended impurities and suitably treated to be scale and corrosion free. If the ambient temperature approaches freezing point, the cooling water should be drained out of the engine, which it is kept idle. During operation, the lubrication system should work effectively and requisite pressure and temperature maintained. The engine should be of correct specification and should be in a fit condition to lubricate the different parts. A watch may be kept on the assumption of lubrication oil, as this gives an indication of the true internal condition of the engine. The engine should be periodically run even when not required, be used, and should not be allowed to stand idle for more than 7 days. Air filter, oil filter, and fuel filter should be periodically serviced or replaced as recommended by an manufacturer, or if found is an unsatisfactory condition upon inspection. Periodical checking of engine compression and firing pressure and also exhaust temperature should be made. The engine exhaust usually provide a good indication of satisfactory performance of the engine. A black smoke in the exhaust is a sign of inadequate combustion or engine overloading. The loss of compression resulting from wearing out of moving parts lowers the compression ratio, causing inadequate combustion. This defect can be checked by taking indicator diagram of the engine after reasonable interval. Types of diesel engine used for diesel power plant. The diesel engine may be 4-stroke or 2-stroke cycle engine. The 2-stroke cycle engine are favored for a diesel powered plant. Efforts are being made to use dual fuel engine in diesel power plants for better economy and proper use of available gaseous fuel in the country. The gas may be waste product, as in the case of sewage treatment installation or oil fuels, where the economy advantage is self-evident. With the wider availability of natural gas, the dual fuel engine may become attractive means of utilization gas or fuel at peak of tariffs. Working dual fuel engine. During the various strokes of dual fuel engine are as follows: suction stroke, compression stroke, working or power stroke, and another one is the exhaust stroke. Suction stroke: during the stroke, air and gas is drawn in the engine cylinder. Compression stroke: during this stroke, the pressure of the mixer drawn is increased. Near the end of this stroke, the pilot oil is injected into the engine cylinder. The compression heat first ignites the pilot oil and then gas mixer. Working power stroke: during this stroke, the gas expands and thus power is obtained. Exhaust stroke. The exhaust gases are released to the atmosphere during the stroke. Layout of a diesel engine power plant. The most common arrangement for diesel engine is with parallel center lines with some room left for extension in future. The repair and usual maintenance work connected with such engine necessitates sufficient space around the unit, and consideration should be given to the need for the dismantling and removal of large components of the engine generator. The air intakes and filters, as well as the exhaust and mufflers, are located outside the building or may be separated from the main engine room by a partition wall. The latter arrangement is not vibration free. Adequate space for oil storage and repair shop as well as for office should be provided close to the main engine room. Bulk storage of oil may be outdoor. The engine room should be well ventilated. Storage and shop, washroom, switchboard, office hall. Space for future unit, exhaust silencer, unit 3, unit 2 and unit 1. Compressed air bottle, air compressor unit, front entrance. Now, the engine, actually any type of machine which drives heat energy from the combustion of fuel or any other source and converts this energy into mechanical work, is termed as heat engine. Okay. Now, gas turbine. Probably windmill was the first turbine to produce useful work, wherein there is no pre-compression and no combustion. The characteristic feature of a gas turbine as we think of the name today include compression process and heat addition or combustion process. The gas turbine represents perhaps the most satisfactory way of producing very large quantities of power in a self-contained and compact unit. The gas turbine may have an ample future use in conjunction with the oil engine. For smaller gas turbine units, the inefficiencies in compression and expansion process become greater to improve the thermal efficiency. It is necessary to use a heat exchanger in order that a small gas turbine may be compete for economy with the small oil engine or petrol engine. It is necessary that the compact effectiveness heat exchanger be used in the gas turbine cycle. The thermal efficiency of a gas turbine alone is still quite modest, 20 to 30%, compared that of modern steam plant, 38 to 40%. It is impossible to construct combined plant whose efficiency are the order of 45% or more. The following are the major fields of application of gas turbine: aviation, power generation, oil gas industry, marine population. The efficiency of a gas turbine is not the criteria for the choice of this plant. A gas turbine is used in aviation and marine fields because it is self-contained, lightweight, not requiring cooling water. The gas turbine have the following limitation: they are not self-starting, low efficiencies at part load, non-reversibility, higher rotor speed, low overall plant efficiency. In the last 2 decades, rapid progress has been observed in the development and improvement of the gas turbine plants for electric power production. The major progress has been observed in the following direction: increase in the unit capacities of turbine units, increase in their efficiency, drop in capital cost. Okay.
Last, if you like my video, you have to subscribe. Okay, thank you.